Starting with numerical number 1.1. Now here a fan is rotating at 90 revolutions per minute. So this directly says that frequency is given to you, that is 90 revolutions per minute. We will convert it into revolutions per second. So revolutions per second. So to convert it into seconds, 1 minute is equal to 60 seconds. So you will divide by 60. Means at place of minute you will write 60 seconds. Here you have 90. So this and this cancels. 3 3s are 9, 3 2s are 6. So it is 3 upon 2 revolutions per second. Now it is then switched off. The fan is switched off now. If the fan is switched off, of course, the frequency, final frequency is going to be 0. Now it stops after 21 revolutions. Now here capital N is given, that is number of revolutions. Number of revolutions, that is capital N, that is 21. Calculate the time taken by it to stop. So they are asking you to calculate time taken by the fan to stop. But final frequency means it has stopped. So the final frequency is 0. And this is that initial frequency. Time taken by the fan to stop, assuming that the frictional torque is constant. Now if you will study the formula of torque in this chapter, if you see, it is I alpha. If tau is constant, of course alpha is going to be constant. Alpha is nothing but angular acceleration. Now whenever alpha is constant, we can use kinematical equations. Kinematical equations, first we'll look at kinematical equations where there is linear motion, that is v square is equal to u square plus 2as. We also have v is equal to u plus half 280, no, it is half 80. V is equal to u plus half 80 and it is v is equal to u plus 80. So when we will look at rotational motion, this kinematical equations will change. At place of v, that this is linear velocity, we will have angular velocity, that is final angular velocity. This is initial linear velocity. So initial angular velocity. 2 at place of acceleration, angular acceleration. At place of displacement, angular displacement. Similarly, omega, omega naught plus alpha t. This is the conversion of kinematical equations from linear motion to rotational motion. So of course we are going to use this ones because we are in rotational motion. So first we will look at this because it has time. So omega minus omega naught, that is equal to alpha t. So omega minus omega naught upon alpha, that will give us time. We know that omega is nothing but 2 pi n. So here it is 2 pi n final frequency because that is final angular velocity, 2 pi n I because this is initial angular velocity, so initial frequency, that is equal to time upon alpha. Now if I remove 2 pi as common, so it will be nf minus ni upon alpha, that is equal to t. But if you notice, we have the value of nf, we have the value of ni, but we don't have the value of alpha. Now to calculate the value of alpha, we'll go to second kinematical equation, or this kinematical equation which I have written here, that is this one, sorry, to this one will go, that is omega square minus omega naught square, which is equal to 2 alpha theta. So I'll keep alpha over here. So omega square minus omega naught square upon 2 theta. Now again we know that omega is nothing but 2 pi n. So I'll do that substitution. So 2 pi nf minus 2 pi n I, because this is initial angular velocity, the whole square on both the sides, upon 2 theta, that is equal to alpha. Now we have all the values except the value of theta. So we'll not stop over here. We'll do some changes in both the equations and then we'll go to the value of, then we'll move to find the value of theta. Now if I take alpha in this equation on right hand side, so this becomes 2 pi nf minus ni, that is equal to alpha upon theta. So this is your equation 1 and this is your equation 2. So if you notice in equation 1 and equation 2 on right hand side, you have alpha in both the equations. So can I write these two equations are equal? Yes, of course we can write. So I'll write 2 pi nf minus ni upon t is equal to 2 pi nf the whole square minus 2 pi ni the whole square upon 2 theta. Now two pi nf minus ni upon t, which is equal to, now this 2 pi and this 2 pi, we will have to take square of it. So I'll write 4 pi square. This becomes nf the whole square minus ni the whole square upon 2 theta. So 2 from here and 2 remains, pi from here and single pi remains over here. This 2 and this 2 gets cancelled. So we are left with only pi over here. So now on left hand side we have nf minus ni upon t, that is equal to, we are just left with pi over here upon theta nf square minus ni the whole ni square. Now 1 revolution means 1 revolution in theta, 1 revolution. So how much will what will be the value of theta? It will be 2 pi. So if my body is completing n revolutions, theta will be 2 pi into n. So this is the formula of theta. Theta is equal to 2 pi n. So at place of theta, nf minus ni upon t, that is equal to pi, and here we'll apply the formula a square minus b square. So a minus b and a plus b, and at place of theta I'll write 2 pi n. So this and this will get cancelled. So now it is, you can keep this t in the denominator. You have pi over here, you have nf plus ni, nf is 0, ni is 3 upon 2, and this 2 pi n. So now we have all the values. We can calculate t. Just shift this t over here. 2 2s are 4 pi n, and this 3 pi in the denominator on this side, also 3 pi. So this pi and this pi gets cancelled. So 4 into the value of n is 21 upon 3, 3 7s are 21. So time is 4 7s are 28, second is the time. So the fan will stop after 28 seconds.